Welcome back to Drug Calculations with Nikki. Today we're going to be talking about Clark's rule. So basically, Clark's rule is a way to figure out dosing for pediatric patients. So it's always going to be the child's weight in pounds, and LB or LBS is the abbreviation for pounds, and it always must be in pounds or else your calculation will not be correct. So if this is in kilograms, you need to convert it into pounds before you can plug it into this equation. It's always going to be over 150, and this 150 is derived from the average adult weight in pounds. This number will never change. That's why it's so important to make sure that your child's weight is in pounds, because it won't make sense to have kilograms divided by pounds. That's going to give you the wrong answer. So always make sure that's in pounds. Then you take that times the usual adult dose, and that will give you your answer. And your answer is going to be the dosage that you will use to plug into your formulas. And that'll just be your basic drug calculation formulas that we've been using, the drug calculation with or without conversion. That is the first part of the equation that goes over 1. So you use this formula to get the dosage, and then you plug it into that formula. Or if she just asked just for this part, then obviously you don't need to go any further. So let's go ahead and try out one of the sample problems that she gave us. And I am just using this worksheet. This was the practice problems for Clark's rule. So I'm going to look at number 3 on this worksheet. So this one said the child's weight in pounds is 70. So we put 70, always over 150, times the usual adult dose, in this case 250 milligrams, and then we're going to do our math. Now I did another longer video about this, you guys are welcome to watch that, but I'm just going to keep this one short. So basically what I discussed there and what I discussed in the video about doing rounding for drug calculations is that it's important to try to keep rounding until the end of the problem so that you're getting a more accurate answer. So I recommend using a scientific calculator or any calculator that has parentheses on it. I'm not sure how well you can see that there. There's parentheses, and that will give you a more accurate answer. So we are going to put parentheses around this to plug it into our calculator. So we do parentheses 70 divided by 150, close your parentheses, times 250 equals, and then the answer we get is, I'm not sure if you can see it, it's 116.666666, and it just keeps going on and on and on. So in this case, we're going to round that to 116.7, and that is milligrams. And that would be your answer for the first part of that equation. Now it goes on to mention supply. So that tells us that we are going to want to plug this into one of the dosing calculations. In this case, it doesn't look like we need a conversion. So remember, Clark's rule is this equation right here. That's Clark's rule right there. And then that just gives us our dosage, which is this right here. Sorry, I keep hitting my little camera here. Okay, so we are going to take that and we are going to plug that into our drug calculation. So first is dosage, so 116.7 milligrams over 1 times the supply. And the supply we're given is 75 milligrams over 0.5 milliliters. So we want milligrams to cancel each other out. So we put milliliters on top, milligrams on the bottom. Those two will cancel each other out. And that was 75. And always remember, put the 0 before your decimal, 0.5 milliliters. And that's how your equation is going to look like. And once again, this was just your dosage times your supply, making sure that we have the measurement on top that we want our final answer in. In this case, it is milliliters. So let's get our calculator. And we multiply across. So we want to do 116.7 times 0.5, and then it's going to be divided by 1 times 75. And I'm going to use the parentheses on my calculator because I am lazy. And you put 116.7 times 0.5, close your parentheses, then you can do divided by 75. And we don't need to worry about taking that times 1 because anything times 1 is just going to be the same answer. So 75 times 1 is always going to be 75. And that gives us our final answer of 0.778. In this case, because it's in milliliters, we want to take it to the hundredths place since it is less than 1. So our final answer would be 0.78 milliliters. And that is our final answer. Now, if you were going to do this with the conversion, it would just be the same thing. You would just figure out the Clark's rule up here to get your dosage, and then you would plug in your dosage from the Clark's rule times the supply or the conversion times the conversion or the supply. And these two can flip-flop, remember, and that's just going to be based on what measurement you want your final answer to be in. So you always put your dosage over 1 times, and you make sure that you have your final measurement. I'm just going to put F for final right there. So let's say this was in milligrams, then you would want a milligram here. And then let's say that was grams and grams. So milligrams and milligrams would cancel out, grams and grams would cancel out, giving you your final measurement. So basically, the only thing you want to look out for to see if you need to use Clark's rule is, are you given a child's weight in pounds or kilograms? Make sure if it's in kilograms that you're converting it to pounds before you're plugging it into this equation, because remember the 150 will always stay static, which means the same. That's derived from the average adult weight in pounds. So you need to make sure this is in pounds. You take it times the usual adult dose, and that will give you your answer, which is the dosage that you can use to plug into this formula. And you can use this with either the formula without a conversion or with a conversion. It'll work for either one. So when you're doing it, just try not to get confused. Just look for the important information. And as always, I suggest that you either use a highlighter to highlight the important information or get a separate sheet of paper and make sure you're writing down the important information that you need to solve these equations.